welcome back. It was welcoming everybody back from the break. So, hope you had a wonderful week. Hope you got some rest and relaxation in. Hope you did something fun. Hope you know, slept in or stayed up late or both. I've always been a late night person. It's just built in me. I always love the late night hours and sleeping in the morning. I don't care if I don't see the sun rise. Doesn't bother me. Some of them that basically I stay up till midnight every night of the break and sleep in the morning. So come on in. I will say I didn't get crazy about sleeping in. I didn't sleep till noon. Okay, Wednesday I did get up at 11:59, but that is not noon. I'm very specifically that is not. I got up before noon. 1 minute is still before noon. That's the latest. I thought that Wednesday was, yeah. It's like, oh man, 11:59. So yeah, I enjoyed that. So getting up early this morning was just like pretty hard on the eyeballs this morning, but managed to get through it. We'll get back into the school routine for another 8 weeks or so. It'll zip by usually once spring break comes and goes. It's like, oh my gosh, are we almost into the semester? I better get some things turned in. Which, speaking of which, I received a distressingly low amount of late work over the break. I come back today. I'm like, oh, I'm going to grade a lot coming back because I know there's quite a few people missing stuff. Uh, no, there was hardly anything turned in over the break, which is, I'm glad you enjoyed yourself and had a good time. But if you were behind in work, that means you already took weeks off before and didn't do anything then. So you really need to get caught up. So you've had more than one spring break then if you took weeks off earlier and took off last week. So some of you got some work to do because there are some low grades in this class. I see there's at least 6 people that have some distressingly low grades because you're missing programs. And I have put in Google Classroom helper videos for every program, I think. At least the last three, the 4.02, 4.04, 4.06. I know there are videos in Google Classroom like if you're stuck and you don't know what to do, here's a video that will help you. It'll help you write this. In addition to, you have the AI helper for those programs. So there's all kinds of help in Google Classroom for you if you have missed turning in some assignments. I am available to help as well, right? So we'll have class on Wednesday morning. Some of you will need to be here Wednesday morning because your grades are low. But when we have class Wednesday morning, come on in and say, hey, I need help with this. And we can get that done. There's also the in-person virtual lab Wednesday through Friday. You can come in and sit here at the desk and we do programs. I've had several students come here, sit at my desk, and we write some programs. So don't just linger behind because, like I said, it's going to pick up speed now. We are over halfway through. We've only got 8 weeks left. We got a lot of testing coming up later this month, so there's going to be some crazy schedules towards the end of April. I know Atlas testing to come in there. There's just a lot that kind of interrupts our regular schedule, and you get busy with other things. So I don't want you to get stuck at the end of the semester going, oh my gosh, oh my gosh, oh my gosh. So take off the stress, relieve your stress, get things turned. And then let's take a look at what's going on this week. All right, we've got the foundations of programming, intro to computer science right here. Let's go to the grade screen. And we see we are on 5.02. We looked at number systems briefly before the break. And that was just a 5-question quiz. We have decoding ASCII. Decoding ASCII. Oh, let me say this. This is probably one of the easiest programs we write all year because this is the one time that you could pretty much take the sample programs, not exactly take it, but pretty much take it, the sample programs to write the program. Like we're going to, if I remember correctly, Like I say, I haven't looked at this since the break. I slept a lot in the last week. Our program this week is you're going to have a message. You're going to convert it to ASCII and print the ASCII version of the message. Then you're going to take that ASCII message, convert it back to plain English, and print that. Pay attention in our lesson because our lesson has a program that takes a message, converts it to ASCII, and prints it. Hey, that's half of our assignment. There's another program in our lesson that will take a message in ASCII, convert it back to plain English, and print it. That's the other half of our program. So, yes, our lesson pretty much shows how to do the program this week. And yeah, you can borrow and steal from that because that's the only way to really do it. Convert it from ASCII. There's one command that converts things to ASCII. There's one command that converts from ASCII. So you have to use that command, which is in the sample program. But it doesn't exactly do the whole program for you because you got to figure out a little bit of change on how to use the ASCII you just converted in the second half of the program. We'll look at it. But this one's easy because the program gives us everything to write that, except for your message. You got to make up your own message. How hard is that, right? Say whatever you want on your quote there. So, all right, let's put this back up here. So, like I said, this should be a real easy week for program writing. This is the one we've been wanting for a while. Will the program tell me exactly everything to write this program? It will. All right, decoding ASCII. Every time you hit a key on your keyboard or you type a text message, something magical happens. Before the characters you typed appear on the screen, there's lots of things happening in the background. The computer changes each character to a number because computers only read binary, zeros and ones. That's all computers can read. So that's right. Everything you type gets translated into code. So this translated code is actually standard, which means it uses the same number. Every time you type a capital A, it uses the exact same number for it. Everyone, every computer, everywhere, it has the same binary code for an A. All right, after completing this lesson, you're going to be able to describe the difference between data and information. There's a difference. And explain how ASCII and Unicode standards represent characters. Phase 2. ASCII. You may not have heard of ASCII. We communicate on many different machines. You got your Macs and your PCs and your phones and your smartwatches, and we enter data like words and numbers into a wide variety of computers. And we often want to share that information with others. Because computers can read only binary, that information has to be translated. So first, your computer has to understand the keystrokes you've entered. So this includes every character you type, whether you hit enter, whether you hit a space, whether you hit a page break, everything has to be converted to something the computer can understand. So once you share that information with someone else, a different computer has to be able to open it and then read it back exactly the way you wanted it to appear. But what if your computers are different types, right? I'm on a Windows computer, I'm sending it to your Apple computer. Well, that's where ASCII comes in. It's pronounced ASCII, ASCII, the American standard for exchanging information. That means there's a special code all machines use to receive and deliver data. Select the sample chart to see a more complete list. So right here's our sample chart. Opens it up in a new window. Yes, here it is, the table. So this gives us an example of several ASCII characters you convert right here. Like the decimal number 32. In binary, it would be a 1000000, and that is a space when you convert it to stuff we can read. So when you type a space, the binary is this, and 32 is the decimal, right? So the ASCII decimal. And if you do a hashtag, if you do a $, a plus symbol, the numbers 3 actually converts to a 51 in ASCII. You can go down here to letters. 70. I should have worn it today. I have an ASCII shirt that spells nerd. It has, 78. Oh, and there's different ASCII codes for lowercase letters down here. 110. I think I have nerd in all capital letters. It has 78, and then 69, and then 82, and then 68. So I have a shirt that says nerd. But yeah, here's even some of these special characters over here: a quarter, a half, a three quarters, an upside down parentheses used in other languages. Some of these different characters. So this is the ASCII equivalent from 32 to 255. 255 is the highest ASCII there. Down to the lowest one we see is 32 on this table. So ASCII, every character on the keyboard corresponds to a specific ASCII value. Each character is equivalent to 8 bits. 1000101. Because ASCII is standardized code for all computers, it's easier for them to share information this way without losing any data in transition. All right, let's compare data and information. I said there's a difference. Data is a collection of quantities or characters that computers use to perform operations, like a test score. That would be data. Information is a collection of values derived from data that has meaning, like the average of all of your test scores would be information. The individual test scores would be data. Data used to compile together, create information. Data, information. All right, let's go to page 3. Unicode. Right, now I said ASCII goes up to 256 characters. So ASCII is great, but it's limited to 256 characters, and it's designed for languages that use the Latin alphabet, right? Because there's other languages out there that don't use our letter system. In our current global economy, because your computers can communicate with computers all over the world, and hackers know that. That's why they try to connect to your computer from all over the world. It's pretty common for people to communicate across many languages. So what if you need to translate characters into Chinese or Arabic? That's where Unicode comes in. It's a global code that covers a lot more characters than the 256 that are covered in ASCII. Globally, there's a need for many, many more characters and symbols. Makes computers multilingual. So Unicode expands to, here you go, over 1 million characters. That's why we don't have a little table to look at all of those. There's over 1 million characters of Unicode. And more are being added all the time as needed. Example, emojis. You can do emojis. There's a Unicode for emojis. Emojis are Unicode. While a winking emoji may look a little different depending on where you type it. And try that. Type it on Facebook and on Google, on different devices. The winky may not look exactly like this winky. The Unicode character for the winky face is exactly the same, though. So when it sends that winky from my text to your text, it may look a little different on my device than your device, just depending on what the device is. Because it just gets the Unicode symbol for the winky face, and so it displays the winky face however your device displays the winky face. But it's set with the exact same Unicode to go from mine to yours. So here's the Unicode and a crown and a donut and the praying hands, and we got these two symbols over here, the omega. Let's see. Oh, can I click on that and find out? Here it is. The Unicode for winky face is 1F609. That's the Unicode. So when you send that in your text, that's what's being sent behind the scenes. And then the other computer will receive that 1F609 and display the winky face in whatever way it does that. The crown emoji is 1F451. The donut is 1F369. The person with folded hands emoji is 1F64F. The euro symbol, 20AC. Greek omega 0389, A9, not 8, A9. Did you know computers can understand many characters and symbols, but they can't read them very well? Some companies use this weakness to tell the difference between humans and computers. with this CAPTCHA. You've seen these CAPTCHAs. They're getting a little less common, but there's still places you'll run this. It has twisted and distorted letters. It'll be sometimes they're on top of each other almost. That's because computers cannot read those. So if the correct characters are duplicated, it must be a human that typed it in, because a computer, it confuses that. It just sees these twisted, distorted letters and it doesn't understand. We'll know AI is really progressing when AI is able to start reading that caption, but right now it cannot do it. Page 4. Encoding and decoding. Encoding means, put in some kind of code, and decoding means bringing it back from code into something you can read. Humans have been using code for as long as we've existed. Some codes are written like the early hieroglyphics, where images represented ideas in language. You see that like Egyptian tombs, hieroglyphics. Some codes are unwritten, like the friend code that says, hey, we all have to use the bathroom at the same time. I got to use the bathroom. That means let's all go. That's the friend code. A little stronger with the ladies than the guys, but the guys do that a lot of times too. But here we're talking about computer code, specifically encoding and decoding. When you encode something, you take data and translate it into a code. That's encode. This is what a computer does when it turns your data into ASCII characters. When you decode, you take that encoded information and translate it back to human readable information, back into our language. Encoding and decoding have played a huge part in human communication. Early aviation and radio used Morse code. You may be familiar with Morse code, the dots and the dashes. Beep, 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 beep. During world wars, systems were encoded to prevent enemies from intercepting communications. Because you send your battle plans to your generals so they know what to do, but you certainly don't want your enemies to be able to read that if they intercept it. Some of the most difficult war tasks included decoding messages, many of which saved lives and eventually helped end some wars if you could get a surprise attack on somebody. Programming spotlight, Alan Turing. There's movies about Alan Turing. Most likely to build a robot army. He died young, 1912 to 1954. Alan is best known as the father of computer science, specifically AI. As a well-known cryptographer, he worked as a code breaker for the British government during World War II. He eventually broke the Enigma code that was used by the Nazi Germany. So they had an Enigma code that they sent their messages in, and he cracked it and was able to intercept and understand the messages they were sending to their troops. Big thing. You can find movies. Just Google up Alan Turing. You'll find there's movies been made about him. Some of them are pretty good too. Let's take a look at how the process works. Look at the following encoding and decoding examples. All right. Press any key to see what happens when it translates to ASCII. All right. I'm going to hit a capital B. Oh, I got to hit it on here. B. It's a 66. F is a 70. O is a 79. How about this? A 5. 53. Can I hold down the shift and hit 5? No, I don't. No. Okay. Oh, the shift lock. Can I do shift? Oh, the shift and shift lock apparently aren't changing anything. The bracket. So 91 and 93 is the open and close bracket. The backslash is the 92. This 96. The space is the 32. We looked at that. Period. So all of these have ASCII characters. The 0, the equal sign. That gives you the ASCII. All right, let's look at the next slide. Select translate to see what here's an ASCII message, which we could use that table that we have on the other page. We can go back and say it starts with 89 and 111. So the first thing is capital Y. 111 is lowercase o. I mean, we could go through that character by character, but that's what it looks like in ASCII. Let's see what it says in English. You can use an eraser on the drafting table or a sledgehammer on the construction site. Frank Lloyd Wright. Guy that built house. There's one at Crystal Bridges. Go see the Frank Lloyd Wright house at Crystal Bridges. This is that message. in ASCII. This is the message in English. Which of the following quotation matches the code you see here? All right, so they want us to use the ASCII chart and figure out, does this say your most unhappy customers are the greatest source of learning by Bill Gates? Unless you're breaking things, you're not moving fast enough by Mark Zuckerberg. Innovation distinguishes between a leader and a follower by Steve Jobs. So Grant's already on top of that. He says it's got to be the third one. Really, we only have to check the first letter, right? It's either a Y, a U, or an I. So if we look at the 73, that's all we really have to check. And 73 is a capital I. There you go. Grant was on top of it. Because capital I, it has to be that one. Excellent job. Crack the code. But this is what your computer is going to put out. When you convert something to ASCII, it should print out something like that. And then you're going to convert that ASCII back to English. All right. Yep, you guessed it. Python has an easy way to handle all this encoding and decoding. If you ever need to convert data to or from ASCII, Python's got your back. To encode, use the CHR, short for character function. Right? We're going to change it to an ASCII character. To decode, use ORD, ordinal. Ordinal function decodes characters back to their numerical value, which means it puts it back into something we can read. So let's look how this works. I'm just going to copy this little bit of code right here, open up an idle window. Find main, print the character 65, print the ordinal of A. A and 65, so that's opposite. 65 is the ASCII code, and when we print this, it comes as an A. If we take A and turn it into ASCII, it's a 65. There you go, pretty handy right there. So take an ASCII and put the CHR, and it makes it into a character that we can read. Take a character, put the ORD, it turns it into the ASCII number. So, all right, let's look at the programs that will help us do our assignment this week. So excited to have that. Okay, define main, print, and we're printing one character at a time right here. One character at a time. Print the ASCII character, the ordinal, for A. Notice A has to be in quotes because we want to look literally at an A, capital S, capital C. And it's going to print those 6 lines, including the exclamation mark. Then we're printing the character of the ASCII number 65, the character of the ASCII 83, the character. So first we're going to print one line at a time, and then these we're adding them all together to make a word. Run. 65, 83, 67, 73, 73, 33, ASCII. That's what that is, that when we put all those characters back together. Now, this is not how you want to do your program. Well, we'll get to that. Let's look at the rest of this first. Define main, print, I need 3, and then some ASCII character of 189 feet of fabric for this project. It is 85, ASCII character 176, and cloudy today. Let's look at what 176 is. Oh, look, it's the degree symbol. It's a way you can use ASCII to print these things out where they make more sense. Here, let's just run this. I need 3.5. See, that's the ASCII character for that 1/2, 3.5 feet of fabric. That's a pretty cool looking thing because that's actually looks like a half. 85 degrees. Here's something about llamas. I don't read this language. Como de llamas? Do you have any llamas? No, I'm sure that's not what it says. Solve. Oh, look, 3 squared plus 4 squared. So the 178 is a squared symbol. Raised up in superscript. In London, gas costs. Oh, look there. There is the symbol for the British pound per liter. Character 163. So that's pretty neat. You can use the ASCII character if you don't know how to type this and you want it to look right on your output. Let's see, Grant says, with those two functions, it makes sure you not have to type out every letter you want in the output, correct? Right. We don't want to just type the letters we want. We want to use the conversion back and forth. Let's look at this one. Oh, okay, here it is. Here's the second half of our program this week that we have to write. We have a message as a list. Look, it's a list. And it's all ASCII code. Define main, message equals. We've created a list, and we put all these ASCII in here. And we've created a message that's empty. See, new message equals quote, quote. It's empty. And we used a loop, say for m in message. Message is the name of our list. Go through, and in our new message, one character at a time, because it's going to do this one character at a time, convert each item of the list and add it to my message. It's going to look at the 84. It's going to go over here and say 84 is a capital T. So it'll say this is a capital T, and I'll add it to the new message. Well, the new message is empty at first, so it's going to put a T in there. Then the loop is going to come back again, and it says, okay, what's the next number? 104. So it'll go here, and it'll say 104 is a lowercase h. So it'll go through and say new message equals new message, which is T, capital T, and then we'll add a lowercase h. So we'll have TH in the message. And it will continue to do that until it gets to the end of the list, way over here. And then finally, we'll just print what the message is. We just started out empty, we filled it up, and prints it. Run the program. The safe combo is 9524. Oh, I see why they wanted it coded into ASCII now, so nobody could get into their safe without the decoding it. So this is the second half of our program that we're writing. We're going to have an ASCII list. We're going to create a blank message. We're going to convert it into something we can read and print it. This, we have a message, treasure map hidden behind painting. We have an empty list. We're going to use a loop to go the other direction. Remember, with a list, to add things, we put the name of the list with the append command. Append says, add this to my list. That's different than back here where we add it to our message by doing it with a plus sign. With a list, we add it with the append command, but it goes through one by one, takes each character, M in message, takes the T, then it takes the R, then it takes the E, and it converts it to ASCII and adds it to this empty list, one character at a time. And then it's going to print it one character at a time, the way they have this set up. Print C, comma. You could, I wouldn't mind if you just did this. You don't have to use a loop to print it. Let's just do this. Let's just say we're going to print code message. I don't care if we do that. It just adds the brackets. So you can simplify that to that if you like. Just print the code message. But that is all the code needed right there to create and print an ASCII encoded message. You type whatever message you want right here. Whatever message you want right, which, oh, let me stop and say this. Do not use treasure map hidden behind painting. Put your own message, all right? Don't use their message. That's easy, guys. Just type whatever you want in there. Don't copy it to the point that I actually just copied their message as well. Make it a little bit your own program. Put your own message in there. Song lyric. Your name is, or hey, I'm so-and-so and I'm great, you know, whatever. Just please change. Don't have it say treasure map hidden behind painting. Don't do that. I'm making this as easy as I can, but don't literally do that. And that's so with that, that is the end of the lesson. So Let's look at the template that I have in Google Classroom. Let's go to our template. Let's see, where am I at? Week 30. Here is the ASCII code template. It says, write a program to encode and decode a message. Use the following guidelines. Think of a secret message you want to encode. Again, that's your message. Maybe some famous quote, some favorite lyric, your personal motto, whatever you want. Using the ORD and character functions, encode and decode the message. Every year I get someone who encodes the message, but they don't decode it. And I'll show you what I mean in just a moment. Actually, that's what I put, actually decode the message. Here's some things that's optional. You don't have to do this, but some of you really like to play with your programs and have some fun with it. You could ask the user, hey, guess what my message is? Here's my message in ASCII. Guess what that says in English? You could do that. You don't have to. That's an option. You could also display it in binary. Here it is in ASCII. Here it is in binary. Again, that's only for you super nerds that really want to get into that. Or you could encode it some other way where I added 2 to every number. So the ASCII plus, And, you also have to decode. Whatever you do up here, you got to decode it. Neatly print the encoded and decoded messages. Make sure you write the pseudocode. This one's really simple. Make sure you got your main function, your heading, name, date, description, all that good stuff. Here's an example. Someone said the encoded message, and they printed their ASCII message. The decoded message, try not to become a man of success, but rather try to become a man of value. Albert Einstein quote. Great. Okay, that's fine. And then the questions. But let me show you what I mean about don't just put the print statement. Actually decode the message. I'm going to go back here. Let's look at this again. Decoding ASCII, page 5 or 6. All right. So if I write my program, go right here. Let me open up my idle window again. Here's the mistake I see some people do. All right, I'm going to, Mr. Brock is awesome. I wish he taught all my classes. There you go. I've got a period in there. I've got a dash. I got spaces. I got an exclamation mark. All kinds of good stuff. All right, and I'm going to simplify this to code message. Print code message. Print code. I'm just going to print the code message. I'm not going to use the loop to do it. All right, so if I did this, it's like, okay. And I'll go ahead and add the print. Here is the encoded message. All right, here's the encoded message. I see people do this like, okay, this is great. You're doing the program. Look, I've taken this message and I've encoded it. But then what I see people do is print. Here is the decoded message. Print message. Oh, wait a minute. Can't capitalize print. Oh, maybe they put an extra space in between them. This will not get you 100% of the points. If you look at the output, it looks like the program works. Here's the encoded message. 77, 114, 46, 32, blah, 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 blah. Here's the decoded message. Mr. Brock is awesome. I wish he taught all my classes. What's wrong with this? I did not decode the message. I just printed the message as it was. After I create this code message right here, I have to decode that code message. I have to take this list, use the CHR command down here in this space somewhere. I need to decode this code message. I did not. That's why I put on the template, actually decode the message. Do not just write a print statement with the words typed out. That's all I did here. I just did a print statement with the words typed out. Here's the decoded message. Oh, and some people even worse, they just actually do this. I've seen this as well. Here's the decoded message. Mr. Brock is awesome. I'll shoot all of my classes. Again, this is not the decoded message. This is the original message just printed out again. It looks right, but nowhere did I decode the message. When I run this program, this code message now is filled up with all of this. This is a encoded message. I have to actually go through and decode every one of those to create the original message. Okay, so that's what I mean by actually decode the message. Okay, again, this is in our lesson this week. You just got to figure out how to put those two pieces together. Here's the one page, the fourth screen of that sample program shows you how to encode the message in the ASCII. Back on the third shows how to decode an ASCII message. You got to figure out how to meld those together. Because if you just copy the first one and copy the second one, it's not going to work. It's not going to decode the same message that you encoded in the first half of the program. It's going to do two different things. You got to figure out, that's the one tricky thing is you got to figure out, okay, how do I make this part decode this message? So you got to figure out, I got to change to where it's looking at this encoded message. And if you struggle with that, that's what class is for on Wednesday. You can come see me. You can come up to the virtual lab, any of that. It's not difficult. You just have to go through the steps logically and say, if I want this to decode that message, what do I have to tell it to do? Because that's not what it's decoding. It's decoding the sample message that they put in there. The safe's code is 25 or whatever, 24. That's what it's decoding. You don't want it to decode that. You want it to decode whatever message that you encoded in the first half of the program. That's the only tricky part of the thing. And it's not really tricky. You just have to step through it and make sure you're referring to the right list, right? Not their list, the list you created when you encoded whatever message you type. So have some fun with this. Pick out a fun message. Do something cool. See, I had fun with mine. Hey, Mr. Brock, this is cool. So do whatever you want. Hey, Charlie, he's awesome. I'm Charlie. Yeah, whatever you want to put. Lyrics to your favorite song. Some really cool quote. Something you made up. Something you found on the internet. As long as it's school appropriate. I don't care what message you use. All right, guys. If you got any questions, hang around. Otherwise, you can get started on this. Like I say, this one will not take a whole lot. Write the pseudocode. Pseudocode ought to be real easy. Type my message. Here's my message. Probably put your message pseudocode. Here's my message. Convert to ASCII. Print converted message. Convert back to English. Print English message. That's it. That's, what was it, 5 lines of pseudocode? Really quick and easy. And then just do the program. So, like I say, if you need help, I'm here for you. If you're behind on programs, my golly, get caught up. This will be an easy one this week. I expect everyone to have this in before Sunday. I don't think there's a reason to be late on this one because it's so simple that they give us everything in the lesson. You just got to figure out how to put them together. So, all right, have fun with it. I'll let you guys get to working on it. Have a great week, and we'll see you later.